Na as the number of acceptor atoms, Na minus as the total number of ionized acceptor atoms, Ne as the total number of electrons in the conduction band, and Nh as the total number of holes in the valence band. So the total here's the holes will be the um, conduction particles. So the total number of holes present in the valence band will be due to firstly the intrinsic process, that is which takes place in the valence band, where the electrons will be moving towards the conduction band and a vacancy will be created. So the intrinsic mechanism plus the extrinsic process which takes place due to the doping of these acceptor atoms, um, because of um, because of which these acceptor atoms will get ionized, and the process will take place. So the holes, total number of holes in the valence band will be due to these two processes. So first I have taken NH as the total number of holes in the valence band. So it will be equal to Ne, which is the total number of electrons present in the conduction band, plus Na minus, which is the number of ionized acceptor atoms. And Na minus, because the acceptor atoms will gain electrons and they will become negatively ionized. So if we consider the temperature as 0 Kelvin.
Sai,
Yes, ma'am.
let me give you a pause for a minute.
Yes, ma'am.
Students, are you able to get her? Students, she is
Yes, ma'am.
explaining.
Yes,
Everybody
ma'am.
is
Yes, ma'am.
with her.
Yes, ma'am.
समझाई
Yes.
छे बताइने
Yes.
what is
Yes, ma'am.
NH, what is P, what is Ne, what is Na minus.
Yes, ma'am.
Right, whenever you find
Yes, ma'am.
difficulty, you can definitely ask to sign. Okay, she'll surely try to answer the question. Fine. Yes, Sai, continue.
So NH, which is the total number of holes present in the valence band, will be equal to the total number of electrons in the conduction band plus the total number of ionized acceptor atoms. Now, if we consider the temperature as 0 Kelvin, then Ne will be equal to 0, because there is no other energy which is provided to the electrons for moving towards the conduction band. So here NH will be equal to the number of ionized acceptor atoms. That is NH will be equal to Na minus.
Even Sai, we can say that intrinsic process would be suppressed. Intrinsic process would be taken as a negligible, probable process, right?
Yes, ma'am.
When the temperature is low, we can't think that the electron will definitely overcome the energy band gap and they all move to conduction band. Okay, and leaving behind holes. That is the rarely probable process we can think of when the temperature is low. Understood, everybody?
Yes, ma'am.
Yes, ma'am.
Yes, Sai. Continue, please.
So now the total number, for the total number of acceptor atoms, we can write it as the product of the total number of acceptor atoms which are present, multiplied by the probability of finding an electron in the acceptor energy level, which is F of EA. Then we also know that F of EA is equal to 1 by 1 plus e raised to the power EA minus EF by KBT. When we are considering for very low temperatures, we can say that EA minus EF will be very much greater than KBT. So we can consider F of EA as 1 by e raised to EA minus EF by KBT. So the plus one which is there, we can neglect that. Now we will
We did,
substitute.
yes, Sai, let me tell you the other students that which the approximation which we have taken up here. Okay, do we all know approximation? Approximation ખબર
Yes.
છે બધાને? When we consider electron in n type, holes in p type, we have taken approximation. But over here, do you think that approximation is needed, friends? F of EA, rightly Sai said that f of EA is equal to this one raised to -1. Do you understand from this green color font to the black color font how it comes as in equation 3?
Yes, ma'am.
Yes.
What is it? What is it?
Fermi energy level.
What is it? Fermi energy level. But how do you get that 1 plus e raised to EA minus EF by KBT, the whole raised to -1?
કેદને અંશમાં લઈ લીધું ને એટલે એની ઘાત -1
हाँ,
થાય.
साधु गणित है ना? Fine. Continue, Sai. From
So-
denominator to numerator, it is written in that way. Huh. Yes, Sai.
Yes, and then after that, I have considered that for lower temperatures, EA minus EF will be very much greater than KBT. So we can consider the whole thing as for F of E as E raised to minus of EA minus EF by KBT. So here we will be getting the equation of Na minus as Na into E raised to the power EF minus EA by KBT. That minus sign I've taken inside. So we will be getting the EF minus EA. So now as we know that number of holes present in the valence band is due to both intrinsic and extrinsic process, we can consider that the number of holes for intrinsic semiconductor is equal to the number of holes for extrinsic semiconductor. So we can write it as Ni is equal to Nh. That is what I have considered. And in this PDF, it is Pi is equal to Pe. We know that.
Ek minute, Sai.
Yes, ma'am.
Huh. In n-type material, have we dealt with such equation? Have we seen such kind of turning point to get EF, Fermi energy level in n-type semiconductor? Do you remember? And in that case, mostly I've given you the example that number of students are coming to the class. How are they coming? Doesn't matter. They are present, that matters. Do you remember that analogy, example I have used?
Yes,
Yes,
ma'am.
ma'am. वो साइकिल से चल के और BRTS वाला ऑप्शन दिया था.
Yes, yes. How are they coming? Doesn't matter. Where are they? That matters. So in intrinsic, they are in valence band. For extrinsic, they are in valence band. So by using that logic only, I have equated here. Yes, I continue.
So for intrinsic number of holes for an intrinsic semiconductor, we have seen the equation NV into e raised to the power EV minus EF by KBT, and where the value of NV is 2 into 2 pi mh star KBT by h square raised to 3 by 2. And here we have got the equation for number of holes for extrinsic semiconductor as Na into e raised to the power EF minus EA by KBT. So we can equate both the equations. So if we take Na by Nv and both the exponential functions on one side, and if we equate, we will be getting e raised to EV minus EF minus EF minus EA by KBT. And if we simplify that equation, we will get Na by Nv is equal to minus 2 EF plus EV plus EA by KBT. And if we take log on both the sides, so we'll get ln of Na by Nv, which is equal to EV plus EA minus 2EF by KBT. So here, if we just rearrange the terms, we can take ln into ln of Na by Nv into KBT, and we'll bring my EV plus EA to the other side. So minus EV minus EA. And so the final equation we will get as EF is equal to EV plus EA by 2 minus kb T by 2 ln of Na by Nv. So this will be the final equation we get. So if we consider the
Fine.
temperature.
Yes, Sai. Let me ask to other student. Just hold on. Yes, students. What this equation tells me? Equation number 7 tells me that EF is equal to EV plus EA by 2. What is EV? What is EV? Sandeep? Yadav Sandeep? Sandeep, EV and EA. May I know what is EV and EA? Sandeep Yadav, do you hear me? Riddhi Bhojani? Riddhi? Riddhi, please unmute yourself. Give me the answer. Am I audible, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
Okay. Nirali? Nirali, may I know what is EV and EA?
Yes, ma'am. EV is energy of valence electron and EA is energy of acceptor electron.
Very good.
Sorry.
Very good. Yes, EV is the topmost energy level of valence band and EA is for acceptor atom energy level. True. So the equation number 7 tells us that EF is situated somewhere middle of the A and EV, because it is showing us by the first term that EV plus EA by 2 minus KBT and the entire term, the rest of the terms. So Sai will tell us the thing afterwards, what happens when temperature raises or what happens when the temperature is 0. Okay, but when the temperature is 0, what can we see here? Temperature 0 હશે ત્યારે where will be the Fermi energy level in this case?
In between EV
Between
plus
acceptor
EA.
level and
વેલેન્સ બેન્ડ અને
Yes,
પેલા એડોપ્ટર ની
yes,
વચ્ચે હશે એક્ઝેક્ટ.
valence and acceptor in between these two it is situated, but temperature parameter is playing vital role for shifting of Fermi energy level. Do you think so? Is the temperature playing
Yes, ma'am.
role here?
yes, ma'am.
Right.
Yes, ma'am.
Yes, fine, continue. Fine.
It decreases the
Continue.
value.
Fine. It decreases the value of energy, है ना? So it is moving towards what? EV or EA?
It moving EV.
EV. Towards EV.
Very true. Very true. સાઈ તમારું કામ સરળ બનાવી દીધું છોકરાઓએ. When temperature raises up, what will happen? The total energy given in equation 7 would be moving down, and that down towards valence band, down towards EV. Clear everybody? Last time આપણે એક પ્રેક્ટિકલ નું જોયેલો હતો ગ્રાફ, યાદ છે બધાને? N type માટે. Are you all?
Yes, ma'am.
હા, એ P type નો ગ્રાફ પણ જોઈશું આપણે પછી. Yes, you wanted to tell something related to temperature. Continue.
Ma'am, I was just saying that only.
Okay. Right. And the wow factor comes because temperature is 0.
Yes.
Then no wow. When temperature goes up, there is no wow. Yes. For the next part.
So now for the derivation of the total hole concentration for P-type materials. So we know that for number of holes for intrinsic would be NV into E raised to the power EV minus EF upon KBT. And we had considered that P for intrinsic is equal to P for extrinsic. So we can write P extrinsic as NV E raised to the power EV minus, so the EF we are equating with what we had got in the previous equation, that is EV plus EA by 2 minus KBT by 2 ln of NA upon NV. So we will substitute that value in place of EV. And after substituting, we would be getting EV minus EA by 2 kBT plus half of ln NA by NV. And if we split the exponential factor as NV into e raised to power EV minus EA by 2 kBT into e raised to power NA by NV, 1 by 2 into ln NA by NV. So that factor would become as NA by NV raised to the power 1 by 2. So
That
we
is
will be getting,
constant.
yes. And we know that NV's value is 2 into 2 pi mh star kBT by h square whole raised to 3 by 2. So we will substitute that value in the equation, and we will be getting the final equation as a 2 into Na raised to the power 1 by 2. So 2 and Na we've taken together, and 2 pi mh star kBT by h square raised to 3 by 4 e raised to EV minus EA by 2 kBT as the final equation.
Nice one. Good one, Sai. Very nice.
Thank you,
હું જે
ma'am.
PDF શેર કરીશ એમાં અહીંયા ME star છે ભૂલથી, but I have written here the comment. Can you all see the comment? દેખાય છે? comment મેં મૂકેલી છે, PDF છે. Are you able to see the comment? અહીંયા can you see the symbol? Comment I don't think તમને દેખાતી હશે because a screen share માં થાય કે નહીં that I don't know. But when you will get this PDF, you will come to know that instead of ME star, we have to keep here MH star. That was my mistake. Okay, so make it correct when it comes to you. Okay, I hope everybody is getting what she has explained. બધાને સમજ પડી ગઈ?
Yes, ma'am.
Yes, ma'am.
Thank you
Yes,
so
ma'am.
much, Sai. Thank you very much. So the claps are for you from my end.
Thank you, ma'am.
Okay. So let us have